Okay, so we're going to talk about the periodic table in more depth. So you guys should recognize the periodic table like this. There are 7 periods, those are your horizontal rows, and there are 18 groups across the top. Go ahead now, before you do anything else, and label those groups 1 through 18 from the left-hand column as hydrogen all the way across. Don't worry about the 2 at the bottom. They don't have group numbers. And that's because they're pulled out of the table. And you can see in this example of the periodic table, there's actually a blank spot where those are pulled out. Okay, and this is just one way to represent those. Okay, go ahead and pause if you need to, and then come back. Okay, we're going to talk about metals. Metals are most of the periodic table. They're shiny, malleable, ductile. They're not always solid at room temperature. In the case of mercury is liquid at room temperature, gallium is liquid at very close to room temperature. If you put it in your hand, it melts. And so if you ever see a magic melting spoon trick, they probably used gallium. Definitely don't drink the tea. Um, so everything on this periodic table that's shown in blue is a metal. So go ahead and pick your own color. It doesn't have to be blue. Just make sure that you record it as a color key somewhere on your table where you haven't written or you have extra space. And pause this and go ahead and color everything that you see that's blue in your chosen color. All right, now let's look at nonmetals. Nonmetals are on the right-hand side of the periodic table. Many of these elements are gases at room temperature, like nitrogen and oxygen, and most of the halogens and all of the noble gases. So the photos in this slide actually represent every single one of the nonmetal elements in the table. Okay, and they're actually grouped together based on where they're at on the table. So you've got your noble gases across the bottom. Your halogens are the right-hand side of the center. You've got carbon on the left. You've got your sulfur group elements, so your oxygen, sulfur, and selenium on the upper left-hand corner, and you've got your nitrogen and phosphorus in the upper right-hand corner there. Okay, and so those are all of the nonmetals. Compared to metals, there's not very many. All right, so everything highlighted in yellow on this table is a nonmetal. Okay, so I'm going to go ahead and have you guys pause this, color everything that's yellow on this table and your chosen color. Remember to put it um, on your key, okay? And then on the bottom here, there is a few elements that are gray, and that's this set right here. You can leave those blank, but those are elements that we aren't sure what they are. They're too unstable to study, so we leave them gray. Okay, and we're back. Metalloids are elements that create the staircase. So these are right between your metals and your nonmetals, and they're pretty much everything that's left on your periodic table. So these elements have properties of both metals and nonmetals, as well as a few unique properties of their own, like semiconductance, which is something that pretty much only metalloids do. Silicon is a metalloid that was vital or very important to the development of the modern modern computer, not periodic table. So silicon is the primary thing inside of a computer chip. It's what makes computer chips work. And they actually grow the crystals and then they grade computer chips processors on how well or how perfect that crystal has grown to the template they gave it. All right, so everything you see in orange on this table is your metalloid staircase. So that's boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Go ahead and color those in. You can pause if you want to. It doesn't have to be orange. Just pick a color that's contrasting with the other two you've got on there so that you can pick them out real easy. All right, now let's talk about the special groups. You should have numbered across your table. Group 1 is the most reactive group of metals. It's the leftmost column of the periodic table, the one that starts with hydrogen. So alkali metals like to give up a single electron and they form +1 ions, and that's why they're so reactive. In fact, they're often stored in an inert liquid to keep them from reacting to the air and exploding on contact with the air, moisture in the air. So these include things like lithium metal, sodium metal, cesium metal, francium metal. Okay. Now, sodium in a compound is totally harmless. That's table salt. Okay. And most of these, if they're in a compound, they're pretty non-reactive. But once they start to break down, then you have to worry about that explosion issue. Group 2 is the next column to the right of the alkali metals. It's called alkali earth metals. These are your second most reactive metals. So these metals give up 2 electrons. They form 2+ ions and compounds. Some of these are essential for life. You have to have magnesium and calcium um, to function as a person. Like they're trace elements that you need. You need calcium for your bones. Um, and then radium is one that I talk about pretty frequently because it's highly radioactive. And it's actually this picture right here. And it used to be used to paint watch faces. So the girls who painted the watch faces with radium ended up getting radiation poisoning. And there was a big thing. They made a huge push on worker safety because of their experiences. And several of them did, unfortunately, succumb to that radiation poisoning. Now, we're going to go all the way to the other side of the periodic table to the rightmost column. Group 18 is our noble gases. These are the least reactive elements on the periodic table. They were the elements that almost made Mendeleev give up on his periodic table because when argon was first found as the first noble gas, it didn't fit any of his patterns and it didn't have a spot on the table. And so once they started finding the other noble gases on Earth, then they were like, oh, okay, we just forgot a group, and they added a column to the periodic table. So this is helium, neon, argon, krypton, xenon, and radon. And then you can see their colors right here in the middle. So that's when just energy has been given to them and their electrons are just moving around. They're not actually reacting to anything. It's just their electrons giving off their colors, kind of like the flame test. Right to the left of those is group 17. That's our halogens. So this is the second column from the right-hand side. They're extremely reactive nonmetals. They're mostly gases. And so these like to take in 1 electron and they make -1 ions. So this is fluorine, chlorine, bromine, iodine, and astatine. Iodine or iodine, and astatine are the solids. Bromine is a liquid, but it turns into a gas very close to room temperature. Chlorine and fluorine are always gases at room temperature, unless they're in a compound. So sodium chloride, sodium and chlorine put together, that's table salt. Groups 3 through 12. So this is the center of the periodic table that's shorter than the rest. So these elements have d shell electrons that let them bond in unique ways. They also are metals, so they share electrons differently than most other things. There are too many of these to show them all, so we've got just some fun drawings and some examples of what they look like. Most of them are shiny and gray or silver in color. But you also have gold. And so they pretty much all have the same or similar properties, just of varying strengths of hardness and malleability and brittleness. So these are things like titanium, iron, nickel, copper, zinc, silver, tin, platinum, and gold, right? So pretty much the only things in there that aren't gray colored are copper and gold. So that's why I didn't just put a bunch of pictures of these up. Okay, now we're going to talk about the 2 rows that are below the periodic table. Those are actually special groups. They don't really fit with anything else, so that's why they're pulled out of the table. Plus, if they were in there, it wouldn't fit nicely on a page, and it's created as a reference. So it's meant to be a reference document, and if it doesn't fit on a page easily, it has no use as a reference document. So now we've got the lanthanides. The lanthanides are the first row of elements of the pulled out section at the bottom of your periodic table. These include things like neodymium and ytterbium. Some of these are radioactive, some of them are not. Several of the lanthanides form colored ions, which is really cool. But we don't actually deal with these a lot in chemistry, which is why there's not a lot of info on here, but I want you to know what they are. And then the actinides is the second row of that pulled out area. Almost all of these are reactive or have a commonly found reactive ion. So berkelium is the rarest naturally occurring element. It's no more than a few atoms at a time, and these are only found in uranium deposits. The two photos, the one on the left is thorium, the one on the right is actinium, which gives the name to this row of elements. Uranium and plutonium are actinides. These are our two main sources of radioactive power, whether that be used for weaponry or used for just like power for our power grid. Curium is so radioactive that it glows purple, and that was actually named after Marie Curie because of her extensive work with radioactive materials. Okay, so that's pretty much it. You can check out more in the SWAY that's been linked in your assignment. It has some of this information, and then it actually has just a little bit more and some other pictures and stuff about each of the groups. It actually talks about some of the groups we didn't talk about as well. So if you're interested and you want to do that extra content, it is definitely there for you guys to check out. And I will see you in the next video.